Okay, everybody. This is my first try at video listening, so we'll give it a go as best we can. We're going to start graphing the tangents and the cotangents today. We're going to start with our basic tangent graph, and we're going to grab everything off the unit circle. So when we're at 0 pi, we're looking to find out what tangent is. We're at the point here, 1, 0, keeping in mind that tangent is y over x or sine over cosine. So y over x would get us 0. When I move to the next quadrangle up here, we'd be at the point 0, 1. So I'm looking for y over x. That puts a 0 in the denominator, creating this to be undefined. When we hit a point that's undefined, it will create an asymptote. Moving over to just pi, we're at negative 1, 0. Y over x again would get us 0. And if I move to 3 pi over 2, we're at 0, negative 1. Y over x again becoming undefined. I can't really draw a whole bunch of the graph just from these points in the asymptote. I want to take a look at negative pi over 2, which would make us go the opposite direction. So that would get us, again, to y over x, making that undefined as well. Our parent tangent graph is normally between negative pi over 2 and pi over 2 with a 0 at the origin. Let's look what happens when we get to pi over 4. The coordinates there are square root of 2 over 2, square root of 2 over 2. Again, y over x, if I put the y over the x, we will get 1. And if I'm at negative pi over 4, we're at square root of 2 over 2 over negative square root of 2 over 2, getting us at negative 1. This is what's creating the basic shape of our tangent graph. Tangent is cyclical, or its period is just pi units away, so that is a full cycle. From there we can just start the repetition. So that is what the graph looks like. Just going through, it will stretch and shift the same way as the sines and the cosines. It will not have an asymptote because it continues on in both directions. So we're going to call that the stretch. The coefficient here would therefore be 1. As mentioned before, the period would be pi. There's no phase shift because there's nothing in the parentheses. There's no vertical shift, there's no plus or minus on the end. There's no reflection because it is positive. For the asymptote, since none of them are running through the y-axis, we'll just list the 2 on the left and the right. So dot, 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 negative pi over 2, pi over 2, dot, dot, dot. Okay, moving on. Okay, moving on to the next problem that we have. Okay, not wanting to cooperate a little. Right, moving on. We're looking at y is equal to 3 tan x. The only difference between this graph and the previous one is now the coefficient is the 3. As before, I'd like you to fill out the pieces on the side before graphing. The stretch here, instead of 1, is now 3. The period has not changed, and the normal period for tangent is pi. There's been no phase shift, no vertical shift, no reflections. The asymptotes will answer after we get everything in. Again, since there's been no shifting of anything, your normal asymptotes are at negative pi over 2 and pi over 2. We did not shift up or down, so we are going to start at the origin. But instead of stretching to 1, we now have a stretch of 3. And that's going to create our tangent graph. From there, you would continue to make your graphs with the repetition. On the other side, and there is our tangent graph. Again, our asymptote is not running through the center, so it's going to be just listed as negative pi over 2, pi over 2, and the dot dot dots are showing that it's continuing in both directions. Okay, so let's move on to our next one. We're going to be looking at, okay, y is equal to tan x plus pi over 2 plus 1. We're going to fill out the pieces here. Since there's a 1 coefficient in front of the tangent, the stretch will be 1. Since the coefficient in front of the x is 1, means the period has not changed, so the period will be pi. We do have a phase shift. We solve our phase shift by solving what's in the parentheses and setting it equal to 0. So x is equal to negative pi over 2. So the phase shift is negative pi over 2. Keeping in mind when solved, it is showing the true direction, so this will be to the left. We also have a vertical shift of 1 up. Since the entire function is positive, there is no reflection. When graphing these, I like to move the middle line first, that vertical shift. So I'm going to move that to plus 1. For tangent, when we shift with a phase shift, you will move the center. So the center would normally be on the origin. It's getting moved up to plus 1, but we're also shifting it over to negative pi over 2, creating our new center point here. So for tangent, we move that center point first, then we spread the period out evenly to the left and right. Since the period is pi units, we will spread it pi over 2 to the right, and then pi over 2 to the left. So now we have our center point, our asymptotes. The stretch was just 1, and that creates our tangent curve. For the remainder of this video, just for sake of time, I'll only do one other repetition of these. For you guys, though, you will need to fill out the entire graph. The asymptotes now are running through the center, which means I want you to list all 3. So it's going to be negative pi, 0, pi, and continuing in both directions. All right, looking at example number 4. We are looking at one of these kinds where we have a special graph. If we have this kind of graph, you just need to show me one period. You don't have to show me all the rest of the repetitions with these. So I'm looking through here. I see I have a stretch of 1/2. We never include the negative when we're talking about the stretch. The negative out there is just showing that it does actually have a reflection. Since there is a coefficient in front of the x, that means we do have a period change. So the period for tangent is normally pi. It's being divided by pi, which means this guy has a period of 1. There is no phase shift, and there is no vertical shift. Asymptotes we will list after we get the graph in there. So normally, tangent will start at the 0. Since we have no phase shift, we're just going to spread evenly in both directions. You could pick any number of units on each side. It just has to be the same. I'm going to choose 2 in this case, creating an asymptote here and here. Since our period is 1, that means we need to spread each part equally. So we have 1/2, negative 1/2. This would be 0. This here would be 1/4 and negative 1/4. From there, since it is negative, we're doing a reflection. So normally the stretch would be 1/2, but we're reflecting it over the x-axis. So now it's going to be headed in the down direction, where tangent is normally in the positive direction. For these kind of graphs, you just need to list the two asymptotes that are actually drawn. So -1/2 and +1/2. Okay, one last one with the tangent curve. And we will be looking at one that has a lot of stuff going on. So let's first fill out our piece here. So I see that I have a stretch of 2. It does have a period change again because there's a coefficient in front of the x. The normal period for tangent is pi, dividing it by the coefficient, which means the period's going to be pi/2. It does not have a phase shift. We have no plus or minus inside the parentheses, so there is no phase shift. It does have a vertical shift of 1 unit up, and there is no reflection since the entire function is positive. First put in your vertical shift. That new middle line is sitting there for us. Since we do not have a phase shift, we are going to be starting at the middle line, right on the y-axis there. Now I notice that my period has changed to pi/2, which is making it very, very short, kind of squeezing it in like an accordion. So I need to spread that evenly in both directions. So it's going to be at pi/4 and then at -pi/4. We do have a stretch of 2 that would be happening at pi/8 right in the middle. Just get that estimated in there as best you can. And then we create our, whoops, that wasn't so straight, our tangent curve. Once you have one, you can start the repetition. I'll only have one repeat on each side here. We'll stretch 2, not just 1. And then stretched 2, up and down. Same thing on the other side. 2, 2. And you would continue on to complete the graph. Since our asymptote is not being recorded in the on the origin here, we just need to list the 2. So ... -pi/4, pi/4, ... Okay, we're going to be moving on to our cotangents. For our cotangent, it's going to look kind of the opposite of the tangent curve. Everything else will remain the same, all the same shifting. So let's bring back our unit circle. So over here we're at 1, 0. Cotangent is x/y. So what's going to happen when I go x/y, we're going to have 0 in the denominator, again creating an asymptote. When I move to pi/2, we're at 0, 1. So x/y will get us 0. And then when I move over to pi over here, we're at -1, 0. Again creating a 0 in the denominator, which creates an asymptote. If we continued on to pi/3, we'd be at the point 0, -1. Again, x/-1 would get us 0, back to 2 pi, creating an additional asymptote. Cotangent, like tangent, has a period of just pi. So now we're going to look at the halfway points in between, which would be pi/4. x/y will get us 1. And 3 pi/4, which is over here, which would get us -1. So cotangent looks like a tangent curve that has been reflected over the x-axis. If I was to create another piece over here, the repetition just starts. And you guys, again, would fill out the entire graph. You will notice that the cotangent has an asymptote running through the origin. So we're going to list all 3 of the asymptotes here. So ... negative pi, 0, pi, dot, dot, dot. This had a stretch of 1, period of pi, and there were no shifts or reflections to speak of. Okay, moving on to the next one. Here we're looking at y is equal to the cotangent plus 2. The only thing that changed here is really we're looking at a vertical shift moving up 2, but our stretch is 1, periods stay the same, no coefficient in front of the x, no phase shift, there's no parentheses around that x variable. We're shifting up 2, and there's no reflection because the entire function is positive. Asymptotes will list afterward. First thing I'm going to do is put in the middle line. So our new middle is that vertical shift of up 2. Cotangent will have its left asymptote sitting right on the y-axis. It stretches out a period of pi. It has a stretch of 1, so now our middle point is right here on our new middle line to up. Since the stretch is 1, up 1, down 1, and that will be our cotangent. I could create and start the repetition, and you would just continue to fill out the graph. Our asymptotes in this case, because we do have one that is running through the middle, would be negative pi, 0, pi, dot, 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 dot. Alright guys, turn your pages over. We're going to be looking at, this time, y is equal to negative the cotangent of 2x. Alright, so filling out our piece over here first, there is still a stretch of 1. Again, the negative is never listed with the stretch. There has been a period change because we're looking at a coefficient in front of the x. So normally the period for cotangent is pi. Dividing by 2 is going to get us a new period of pi over 2. There is no phase shift, so that does not apply. There was no vertical shift, but we do have a reflection. Okay, since we have no phase shift, I know my left bounding asymptote will be happening on the y-axis. The next step, anytime you're working with cotangent, is to stretch out the period length to get the second asymptote, the second boundary. Then you're looking at the middle point in between these two, which in this case would be pi over 4. It does have a stretch of 1. Normally we want it to be heading down, but since there's a reflection where the normal spot would be at 1, it's now going to be at negative 1. This one would be a positive 1, creating what does resemble a tangent graph. So the reflections of cotangent and tangent make them look like each other. Once you have the 1 in, you can start the repetition, and you guys will go ahead and fill out the rest of the screen. Our asymptotes are happening at negative pi over 2, 0, pi over 2, dot, dot, dot. Okay, 2 more to go. So we're looking at this guy over here. There we go. Again, this is a different kind of graph, meaning you only have to show me one phase of this. We'll still fill out the pieces and parts that we have here. So let me just move this guy up just slightly. Hold on one second, folks. Just a little bit. There we go. Okay, so we're going to look at this here. We have a stretch of 2. We do have a period change. So normally the period for tangent is pi. Dividing that by pi over 2 is just going to get us 2. So I know my period is also 2. No phase shift, no vertical shift, no reflection. Since we don't have a phase shift, the first asymptote will be occurring on the y-axis. I'm going to spread the period out to 2. I'm just going to say every 2 units here. So that's going to be the 2. we're looking at the center point here, which is right in between here. We'll call that 1. So this will be 1/2. This will be 1.5, or you could say 3/2. Decimal or fractions are fine there. It is positive, so the cotangent should be heading down. So we're going to go up 2 with the stretch, down 2 with the stretch, and it would look something like this. Again, with these graphs, I'm really focusing on these numbers, making sure you have these right. Everyone's graph might look a little different depending on how far you decide to spread that out. Our asymptotes just listed to you actually have, so it'd be at 0 and 2. Okay, we've got one more to go. So now we're looking at trying to get that perfect on here. Hold on. There we go. Alrighty, so we've got a lot of stuff going on with this one. So let's just go through. We've got a stretch of 3. I do have a period change because of the coefficient in front of the x. Normally cotangent is pi divided by 1/2 is going to get us a period of 2 pi. We have a phase shift at well, so you set everything inside the parentheses equal to 0. So x in this case is going to be pi. So phase shift to pi units, it's positive. Once solved, it does show the true direction. We do not have a vertical shift, and we do not have a reflection. With cotangent, with the phase shift, you don't move the center point first, you will move the asymptote. So I'm going to move the asymptote, which is normally on the y-axis, over to where it would be at pi. The next step would be to stretch out the 2 pi units. That would put us somewhere over here. I don't really have enough graph for that, but I do know my new middle point would have been here. I'm going to stretch this one out in the opposite direction so we can see a full unit here. So I need 2 pi, that would bring us to negative pi over on this side, and our middle point would be right here. Since we have no vertical shift, it will be sitting right on the x-axis. We do have a stretch of 3. Since it's positive, cotangent normally heads in the downward direction. Halfway between 0 and pi is negative pi over 2. So be at positive 3 there, here, creating our tangent graph, repeating the process on each side. So our graph will look something like that. Since we do not have an asymptote running through the center, we'll just list off negative pi and pi. Alright guys, I hope that really helped. Remember, you can pause, you can rewind. I will be in next class to take any questions, any review. We'll do a small lesson that day, and the rest of the class will be practicing for the quiz. Thanks for listening, and I hope to do this again with you guys. Talk to you soon. Bye.